In this video, we're going to cover a word problem that deals with solving quadratics by graphing. Here we have a football player kicking a football that's 2 feet above the ground with an initial velocity of 75 feet per second. The function h equals negative 16t squared plus 75t plus 2 represents the height in feet of the football after t seconds. So we see that h is the height as it falls. It starts at 2 feet, it's going to go up, and then it's going to come back down. And t is the time. Now the first question they ask us is to find the height of the football each second after it's kicked. So it might be a good idea to note that at 0 seconds, where is the football? Well, its initial height is 2 feet. So at 0 seconds, it's 2 feet above the ground. 1 second later, we would plug in a 1 into this equation right here. So that's negative 16 times 1 squared plus 75 times 1 plus 2. So we have negative 16 plus 75 plus 2. So that's going to be, 61 feet. So in the very first second, it goes from 2 feet to 61 feet. After 2 seconds, that would be negative 16 times 2 squared plus 75 times 2 plus 2 feet. So we've got 2 squared is 4 times negative 16 is negative 64 plus 150 plus 2, 88 feet. And we can keep going. In the essence of time, I'm just going to go ahead and tell you what these calculations are. At 3 seconds, it's at 83 feet. After 4 seconds, it's at 46 feet. And after 5 seconds, it's at negative 23 feet. Now, there should be a red flag there. We know that the football can't be at negative 23 feet. But obviously, somewhere between here and here, it hit the ground. And then it stops. So this Part B says, use the results of Part A to estimate when the height of the football is at 50 feet. So we know, if we kind of think about this graph, that our football goes up in the air and comes back down. So it should hit 50 feet somewhere on the way up and again on the way back down. So if we look through our numbers, it starts at 2 feet and it jumps to 61. Well, so somewhere between 0 seconds and 1 second, it hit 50 feet. Probably closer to 1 second, so maybe say 0.8 seconds would be a good guess. Then it went up to 88 feet, down to 83, and then down to 46. It obviously hit again in between 83 and 46, it hit 50 feet again. So somewhere between 3 and 4 seconds, it looks like closer to 4, so maybe 3.9 seconds would be a reasonable guess. These are just estimates here. We're not sure exactly, but we do have an idea of between what 2 times that we calculate. We could plug those in and see which one gets us closest to 50, but it's probably going to be easier for us to graph this equation. So we're going to use a graph to figure out when the football is 50 feet above the ground. Now the nice thing about the graph is once we've graphed the curve, we can also graph a line right here at y equals 50 to help us find those exact points of where it hits 50. So grab your graphing calculator and go to y equals, and you're going to plug in the equation. Now chances are you reset the window to something different, and if you go ahead and hit graph, you may not see a good picture of the graph, and we really don't here. So we want to go back to window and select a domain and a range that makes sense for this problem. X is our time, so it makes sense to start our time at 0 seconds. We know that it's already hit the ground by 5 seconds, so I'm going to set my X max to be 6 seconds, just so I'm sure I get the whole picture. Then Y is our height, so the minimum our height can be for our football is 0, and then the maximum height. Well, when we look at our data, the biggest height we got was 88 feet, so I'm going to go ahead and put in a 100 for my max height, and that should give me a decent graph. If once you've made those choices, you don't still have a good graph, keep changing them until you get something nice. Now I told you here's our curve. We can see the football and what it's doing. But we're going to go back to y equals, and we're going to add that second equation of y equals 50, because we want to know precisely when our height is at 50. We see those two spots right there, and they even fit right where we said, somewhere between 0 and 1 second, and somewhere between 3 and 4, but almost right at 4. So we're going to find those zeros. We're going to find where they intersect by choosing calculate and intersect this time. We're not looking for zeros because we don't want to know when the football hits the ground. We want to know when it hits 50. So we're looking for a point of intersection this time. When you're looking for a point of intersection, it's still going to ask you 3 questions: first curve, second curve, and guess. If you'll get your cursor close to the point of intersection but not on it, you just need to hit enter 3 times, and it should say the intersection point right there for you. Our intersection is at 3.9 and 50, so our guess was pretty good right there at 3.9. That's about where it hits. So it does hit at 3.9 seconds. And then we want to find that other point of intersection. So we're going to do second calculate again. We want to find the other point of intersection, so choose 5. We're going to move closer to this other point of intersection so the calculator knows exactly where we want to look. We don't have to be right on it, but closer. We're going to hit enter 3 times. And it looks like it's at 0.76, which is about 0.8 seconds. So both of those guesses were right on. They won't always be, but hopefully we can get close. All right, that's that word problem. That's all we're doing for this one.